Let's talk about something you use every single second of your digital life, but probably don't think twice about: the web application. We're going to pull back the curtain on these hidden engines that power literally everything from your email to your shopping cart.
I mean, seriously, just think about your day so far. You checked your email, you scrolled through social media, maybe you're ordering lunch later. You are constantly inside of web applications. They are the invisible machinery that makes our entire digital world go round.
And look, we're not talking about your cousin's simple blog from 1998. We are talking about the absolute heavy hitters. Gmail? That's not just a web page. It's an entire communication hub. Amazon is a living, breathing marketplace, not some static catalog. These things are unbelievably complex tools, all running right there inside your browser.
And that's the big question, isn't it? All this incredible power and convenience, well, it comes with a pretty big catch. The very same complexity that makes these apps so amazing is what creates all the little cracks and openings for attackers to get in. So let's dive in and take a look at both sides of that coin.
To really get this, we've got to go back in time a bit. The early web, Web 1.0, was basically a giant digital brochure. You could look stuff up, you could read it, but that was about it. You couldn't really do anything. Then Web 2.0 came along, and it was a total game changer. Suddenly, the web wasn't just a library, it was a toolbox.
Okay, so how do we even begin to understand these complex beasts? Well, we've got to break them down into layers. And we'll start with the layer that we all know, because it's the part we see and interact with every single day.
I love this analogy because it's so perfect. The front end is the storefront. It's the fancy window display, the nice layout, the bright colors. It's everything designed to make you want to come inside and look around. It's all about presentation.
So that storefront is basically built with this holy trinity of technologies. First, you have HTML. That's the skeleton, the bare-bones structure. It just says, this is a heading, this is a paragraph. Then CSS comes in. That's the interior designer. It adds all the style, the colors, the fonts. It makes it all look good. But JavaScript? Oh, JavaScript is where the magic happens. That's the code that makes the buttons actually do something when you click them.
But here's where things get a little sketchy. See, your web browser is built to trust the code it gets from a server. It just displays it. So what if a hacker could trick the server into sending your browser their malicious code instead? That's HTML injection. The problem is your browser is just too trusting. It doesn't ask questions, it just does what it's told. And here's how ridiculously simple and sneaky it can be. Okay, picture the comments section on a blog. An attacker, instead of leaving a comment, submits a little chunk of code that perfectly mimics a login box. The website? It doesn't know any better, so it just saves it and displays it. The next person who comes along sees what looks like a totally normal login form, types in their username and password, and bam, that info goes straight to the attacker.
All right, so that's the front end, the shiny storefront we all get to see. But what about the stuff we don't see? Where's all the real work, the heavy lifting actually happening? For that, we've got to go into the back room, to the back end.
Let's stick with our store analogy. If the front end is the showroom, the back end is, well, it's everything else. It's the giant warehouse out back with all the inventory. It's the manager's office processing all the orders. And it's the massive filing system that remembers every single customer. This is the part of the application that actually thinks.
And this hidden engine is really made of three huge parts. You've got the web server. Think of it as the receptionist at the front door, just taking in requests. Then there's the application logic. That's the real brains of the operation, the core code that figures out what to do with those requests. And finally, you have the database. That's the app's long-term memory, where every single piece of information gets stored.
So who are these receptionists of the internet? Well, it turns out it's mostly a few big names. You've got Apache and Nginx running a massive chunk of the entire web. And that's kind of scary when you think about it, because it means if someone finds just one critical flaw in Apache, it could put millions and millions of websites at risk, all at the same time.
Okay, so what about the app's memory, its database? How does it actually work? Well, there are basically two main schools of thought. You have relational databases, which are like super organized spreadsheets. Everything has its proper place. Then you have non-relational databases, which are more like a flexible, searchable filing cabinet. The one a developer chooses has a huge impact on how fast the app is and, as we're about to see, how it can be attacked.
So we have the front end that you see and the back end that does all the work. Now for the really important part, understanding the constant conversation that's happening between them. This constant chatter is called the client-server model. And it's how basically the entire modern web functions. Your browser? That's the client. It's always asking for stuff. The big, powerful computer that hosts the application? That's the server. Its job is to listen and respond. Every single time you click a link, search for something, or post a photo, a new conversation starts. This is happening billions of times a second all over the planet.
Let's walk through it real quick. Say you're on a shopping site and you click on a product. Step 1, your browser sends a request to the server. Step 2, the server's brain, the application logic, wakes up. It goes into the database, its memory, and pulls out the product's price, the pictures, the reviews, all of it. Step 3, the server bundles all that info into a neat little response and sends it zipping right back to your browser, which then draws the page on your screen. And all of that happens in the blink of an eye. It's amazing.
Okay, so now that we get the architecture right, this constant conversation between the client and the server. And because we understand that, we can now see exactly where the cracks are. We can see how attackers try to poison that conversation. Man, this quote absolutely nails it. A vast attack surface. What does that even mean? It means every single place you can type something, a search bar, a login form, a file upload button, is a potential unlocked door for a hacker. And the part about them constantly changing? So true. Every time a developer adds a cool new feature, they might accidentally leave one of those doors wide open.
And that brings us to one of the oldest, most notorious, and still scarily effective attacks out there, SQL injection. So normally, the application politely asks the database a question like, hey, can you find the password for this one user? But with SQL injection, the attacker hijacks that question. They change it to something like, hey, forget that one user, just give me a list of every single password you have, now.
And this is the key, right? This isn't just some abstract technical stuff. This is how real-world damage happens. A SQL injection? That's how hackers get those giant lists of emails for their phishing scams. That file upload flaw? That's how an attacker plants malicious code instead of a profile picture and takes over the whole server. And my favorite example, broken access control. You just change a single number in the website address, and suddenly you're looking at someone else's private account info. These aren't what-ifs. These are the exact flaws behind the massive data breaches you read about in the news.
So, at the end of the day, this is the reality of the web we use. These applications aren't quiet fortresses. They are active, live battlegrounds. It's a relentless, never-ending arms race between the builders creating these amazing tools and the breakers who are trying to tear them down. And the security of your data, of all of our digital lives, just hangs right there in that delicate balance.